the Lumira SDK is located in the Lumira installation folder under Desktop Utilities Vispacker. Okay, the Vispacker is a browser-based development environment which you can open with Google Chrome. So let me do that. Okay, so once you see Vispacker, on the left-hand side you will see the layout design and the data model definition. And on the right-hand side you will see the source code, which is by default shows you a bar chart sample code. We can also preview the chart by clicking on the preview button. I'm going to close it for now. The first step in defining your custom chart is to give it an ID and name for the chart. So what I'm going to do is just name it population pyramid, for example, and give it a name population pyramid. Okay, and click on somewhere outside of this pop-up. Will make it go away. And then I click on the plot area to define the module. So I can give it a name population pyramid module and a name population pyramid module. Click elsewhere, it will go away. And we don't need a legend, so I'm going to close it off. Okay, so the next step is to go to the data model and use some sample data to define dimension sets and measure sets. So I've already copied this CSV file that's listed here in this web page. So I'm just going to upload it. So let me upload it. Okay. Alright, so by default all the column names are put into the dimension set called x-axis. We do need at least one dimension and one measure. Okay, so in this case the only measure that we are interested in is the people column, which shows how big the population is for each age group, for each gender. So I'm going to make that a measure and put it into the default measure group y-axis. Okay, so now our data definition is done. Click on the apply button. The data definition will then be reflected in your sample code. Okay. Alright, so the most things that we will do when converting a D3 chart is to create some JavaScript into this render function. Okay, the render function has some sample code by default, as we saw. So we will need to remove all the sample code as we don't need them anymore. So let me remove all of that. Okay, and we'll then take a little note of what variables you can use in this function. So the variables that's passed into this render function includes a data, which is the data from the CSV file, the container, which is the drawing container, and width and height, and a few other properties. Okay, so what I'm going to do next is to copy over the JavaScript from the original chart. So from here, now we have the entire JavaScript. I'm going to copy that over. Okay, so of course we'll need to have a few things changed in order for it to work in the Lumira environment. The first thing that we need to change is the width and height of the chart. In the original chart, it is hard-coded, and in our container, we have the width and height already defined. So I'm just going to replace that, width and height. Okay, and also we already have an SVG container in the Lumira environment, so we don't need to recreate that anymore. So I'm just going to replace this portion of the code that appends an SVG element to the DOM with viz, which is this variable that's going to be used as the overall drawing container. Okay, so the next step is that we need to replace the part that D3 loads the CSV file. Because we already have the data that's passed into this render function, we don't need this line of code that loads the CSV file anymore. So we should delete this line and its corresponding brackets, of course. So I'm going to here and delete that bracket. For the chart to render properly, we also need the chart's style sheets. So let me go to the original chart and copy over the style sheets from there. And go back to Vizpacker and head into style.css and remove the original content and copy the style sheets over. Okay, at this point of time our chart should render at least. So let me click on the preview button so you can see that our chart has already rendered. Of course it looks a little bit different from the original chart, and one of the major differences is that it has a bluish background rather than the original white background. The reason is that when the chart is rendered in the Lumira runtime environment, all the global cascade style sheets are also applied to our chart. And to solve that issue, we will need to make our style sheets for the chart as specific as possible so that it is not affected by the global style sheets. And the easiest way is to add a unique class name for all the CSS selectors in the style sheet. So for example, for the rectangles, I can add a class name that is equal to the chart's ID, which is SAP viz ext population pyramid. And I'm going to do that for the next CSS selector as well. Okay, and then we'll need to adapt the corresponding JavaScript code that creates all the rectangles to use this class. So let me go to the code section that creates all the rectangles here. So I'm going to add a line of code here saying class equals to SAP underscore viz underscore ext underscore population pyramid. Okay, so let's run this code again. And now you see the chart is now properly rendered. We also want to make sure that all the other CSS selectors have also the unique class name attached. And to save the time, I'm going to just load up a project that has already the CSS selectors with the unique class name. So let me quickly do that. I'm going to load CSS, the profile, and you can see that this one has already all the unique class name that we needed, and all the JavaScript coding that refers to the class names have also been updated. Okay, so at this point of time, our code should be working completely fine, and we can import the chart into Lumira desktop. But I'd like to hold up a little bit before doing that, and because I would like to make our chart a little bit more accommodating in terms of the data structure it accepts. Because the original chart has some hard coupling with the CSV document's column names. For example, in the code, you can see things like d.people, d.year, d.age in the code. And what if I have a document that doesn't use people as the number for population, but rather a column named population rather than people? I would like to make the chart to be able to recognize that as our measure to be used. Lumira SDK provides us some API to be able to dynamically refer to measure sets and dimension sets, and I'm going to do that quickly now. So first of all, I'm going to create the meta variable that refers to the data.meta variable, and then I'm going to define dimensions equal to meta.dimensions. Since we only have one dimension set called x-axis, so this is that dimension set. And then I'm also going to call the population the y measure equals to meta.measures, and we will only have one measure set, which is called y-axis. And since we only have one measure in that measure set, I'm going to just refer to the first element in that array. Okay, so now what I'm going to do is I'm going to replace all the statically referred column names with my dynamic names defined here. For example, I'm going to change the d.people to d y measure d y measure. And since we are using this dynamic column name, so we can't use the dot notation anymore. We have to use the square bracket to refer to the dynamic column name or measure name. Okay, so for the d.year, I'm going to replace that with d dimensions, the first element, first dimension in that dimension set. I'm going to copy this over. And d.age, I'm going to replace that with d hard bracket dimensions element 1 and replace those. Okay, so there are also other occurrences of all the statically referred column names, and to save time I'm just going to load up a project that already has replaced all these static occurrences. And okay, now we have all the replacement that we need that you can see here, for example, and our code should be working fine now. Okay, so now we are ready to import our chart into Lumira desktop. But let me first save the project. If I click on the Save button, it goes to my Chrome download folder. It has an extension named Profile. I'm just going to copy that over to my desktop, and then I'm going to package it. Click on Pack, and it gives me this sap.vis.extension.populationpyramid.zip. Okay, click on that. The zip file will show up in my download folder. So I'm going to move it to my desktop as well. Okay. And the next step is to unpack the zip file. And go to the extracted folder. Go to Bundles. You will see this chart located in SAP Viz extension population pyramid. You can find all the source code here. Okay, I'm just going to copy this entire SAP folder to the Lumira Desktop's extensions folder, and go to Bundles and paste it here. Okay, so now we need to restart SAP Lumira to make sure the new chart takes effect. So launch up SAP Lumira. Okay, and create a new data set. And I'm going to use this new format of the data set where you will see some changes to the column names. For example, population instead of people, gender instead of sex, and the year and age columns have an uppercase in the first letter. Okay, so let me create it. Okay, now you see there is one new button here that basically contains all the chart extensions, and then I'm going to select the population pyramid chart that we have just imported. Okay, so let me add year as the first dimension, age as the second dimension, gender as the third dimension, and population as the only measure. Okay, so now you see this chart is working in Lumira Desktop. We can also use the left arrow keys to go back in history, and the right arrow key to go forward in history.